Challenges in ADaM specifications. Introduction. Creating CDISC ADaM analysis data model specifications in clinical trials present several challenges, largely because ADaM datasets are intended to provide clear and traceable support for statistical analysis while adhering to rigorous regulatory and industry standards. Here are some of the key challenges. Number 1. Ensuring compliance with CDISC standards. Challenge. ADaM datasets must strictly comply with the CDISC guidelines, including the ADaM Implementation Guide IG. Interpreting and applying these rules consistently can be complex, particularly for nuisance cases. Impact. Non-compliance can lead to regulatory rejection or the need for rework, delaying submission timelines. Solution. Standardized templates and guidelines. Use CDISC compliant templates for ADaM data specifications and datasets. Regularly update them to reflect the latest implementation guides. Training. Provide training on CDISC standards for all team members to ensure consistent interpretation and application. Validation tools. Use tools like Pinnacle 21 or SAS Clinical Data Integration to check compliance with CDISC standards before submission. Number 2. Aligning with Statistical Analysis Plan SAP. Challenge. ADaM datasets must align with the SAP to support pre-specified and ad hoc analysis. Misalignment between ADaM datasets and the SAP can lead to incomplete or inaccurate analysis. Impact. Late-stage corrections or reprogramming might be required, consuming resources and increased cost. Solution. Cross-functional collaboration. Establish regular meetings between statisticians, data managers, and programmers to ensure alignment with the SAP. Detailed specifications. Develop detailed ADaM specifications that explicitly map analysis variables to SAP requirements. Iterative review. Perform iterative reviews of draft datasets against the SAP to identify and address gaps early. Number 3. Handling complex study designs. Challenge. Oncology trials, crossover studies, and adaptive trials often involve integrate designs that are difficult to represent in standardized ADaM datasets. For example, oncology endpoints like progressive free survival (PFS) and objective response rate (ORR) require careful derivation and traceability. Impact. Incorrect derivations or misrepresentation can lead to misinterpretation of results. Solution. Customized specifications. Tailor ADaM specifications for unique study designs, ensuring they address specific requirements like oncology endpoints or adaptive trial rules. Experienced resources. Engage experienced programmers and statisticians familiar with complex designs like oncology and crossover studies. Test scenarios. Create mock datasets and test scenarios using the design phase to validate derivations and ensure robustness. Number 4. Deriving complex variables. Challenge. ADaM requires derived variables to be traceable to the raw data, but creating variables such as visit windows, treatment durations, or derived endpoints can be highly complex. Impact. Errors in derivations can compromise traceability, transparency, and the credibility of analysis. Solution. Standardized derivation rules. Document and standardize derivation rules for commonly used variables such as time to event endpoints and visit windows. Automation. Use automated scripts or macros to minimize errors in derivation. Validation. Implement dual programming or independent validation to ensure accuracy and consistency. Number 5. Integration with other CDISC standards, for example SDTM. Challenge. ADaM is built on the foundation of SDTM, which is Study Data Tabulation Model datasets. Inconsistencies or errors in SDTM can cascade into ADaM. For example, if the SDTM data doesn't capture all the necessary raw data, creating ADaM datasets that support required analysis can become challenging. Impact. Additional programming or manual work might be required to fill gaps. Solution. Early coordination. Ensure SDTM datasets are complete and accurate before initiating ADaM creation. This requires close collaboration between SDTM and ADaM teams. Traceability metrics. Create traceability matrices that link SDTM variables to ADaM variables. Proactive gap identification. Identify missing or incomplete SDTM data during the specification phase and address them promptly. Number 6. Ensuring traceability and transparency. Challenge. ADaM datasets are designed to be analysis ready with clear links to SDTM datasets and raw data. Maintaining proper traceability, particularly in highly derived variables, can be time consuming and error prone. Impact. Failure to demonstrate traceability can lead to regulatory scrutiny. Solution. Detailed documentation. Include clear step-by-step documentation of derivations and links to source data within the ADaM specifications. Traceability tags. Use traceability variables like src, seq, param-cd and eval-c to maintain transparency connections between datasets. Validation reports. Generate traceability validation reports to confirm the integrity of the dataset. Number 7. Collaboration between teams. Challenge. The creation of ADaM specifications requires collaboration between statisticians, data managers, and programmers. Miscommunication or differing interpretations of requirements can cause delays. Impact. Rework and inconsistent deliverables may result if stakeholders aren't aligned. Solution. Communication tools. Use collaboration platforms, for example, Microsoft Teams, Jira, or Slack, to enhance communication and transparency among teams. Role clarity. Define roles and responsibilities clearly for statisticians, data managers, and programmers to avoid overlaps or miscommunication. Kickoff meetings. Conduct specification kickoff meetings to ensure all stakeholders understand requirements and timelines. Number 8. Version control and updates. Challenge. As trial data evolves, for example, interim analysis, database updates, ADaM specifications often need revisions. Managing version control and ensuring all updates are reflected consistently across all documents is critical but challenging. Impact. Lack of synchronization can lead to errors in final datasets. Solution. Version control systems. Use tools like GIT, SVN, or a clinical data repository to manage versioning and track changes to specifications. Change management. Implement a formal process for managing updates, including impact assessments and approvals. Regular updates. Schedule periodic reviews to ensure specifications and datasets remain synchronized with evolving data and analysis requirements. Number 9. Supporting regulatory submission requirements. Challenge. Regulatory agencies like the FDA and the PMDA have specific expectations for ADaM datasets, including compliance with define.xml, reviewer guides, and metadata. Ensuring these requirements are met adds complexity. Impact. Failure to meet these expectations can delay approval processes. Solution. Regulatory awareness. Stay updated on regulatory expectations through training, conferences, and CDISC workshops. Reviewer guides. Create ADaM reviewer guides ADRG to accompany datasets, providing regulators with a clear understanding of their structure and derivations. Automated tools. Use tools like Pinnacle 21 to ensure datasets meet FDA or PMDA submission requirements. Number 10. Handling large and diverse datasets. Challenge. Clinical trials, especially global ones, generate large volumes of data with diverse formats, requiring harmonization and standardization before ADaM creation. Impact. This increases the time and resources needed for data processing. Solution. Efficient ETL processes. Use extract, transform, and load ETL pipelines to standardize and harmonize raw data before creating SDTM and ADaM datasets. Scalable infrastructure. Leverage cloud-based or high-performance computing systems to handle large datasets efficiently. Modular programming. Break down dataset creation into smaller, manageable modules to streamline processing. Number 11. Training and resource constraints. Challenge. Teams must have expertise in CDIS standards, ADaM structure, and regulatory expectations. Lack of training or resource constraints can hinder specification development. Impact: increased dependency on a small pool of experts, slowing down progress. Solution: ongoing training. Provide regular training sessions on ADaM standards, tools, and regulatory expectations. Knowledge sharing. Encourage knowledge sharing within the team through mentoring and collaborative forums. Outsourcing. If resources are limited, consider outsourcing to vendors experienced in CDISC ADaM creation. Number 12. Adapting to evolving standards. Challenge: CDIS standards are updated periodically. Keeping up with these challenges while ensuring existing specifications remain relevant can be demanding. Impact: delays and inefficiencies in adapting to new standards can affect trial timelines. Solution: continuous learning. Monitor updates from CDISC and regulatory agencies to stay ahead of changes. Scalable frameworks. Design ADaM specifications with scalability in mind, allowing for ease updates to align with new standards. Feedback loops. Use feedback from prior submissions to refine processes and adapt to evolving requirements. Conclusion: mitigation strategies. Training. Provide regular training on CDIS standards for team members. Tools. Use automated tools and templates to streamline data creation and ensure compliance. Communication. Foster collaboration between statisticians, programmers, and data managers. Quality control. Implement robust validation and quality control checks to catch errors early. By implementing these solutions, organizations can overcome the challenges of creating ADaM specifications, ensuring timely and compliant data delivery for clinical trial analysis and regulatory submissions. Please like, share, and subscribe. Leave a feedback comment mentioning any topic that you want me to make a video. Looking forward for a positive response. Thanks for watching. Please like, share, and subscribe. Leave a feedback comment. Many thanks for your support and having great connection.